Oh, it's good. It's loud. A bit nervous, but it's great to see everyone here. I'm Paulo Valim, and I'm here today to talk a little bit about training Elixir teams. But first, let me tell you a little bit about myself and the work I do. I'm relatively new to Elixir and programming in general, but I've always been passionate about teaching and education, and chemistry too. We're going to see soon. But before I started diving into code, my journey began in a very different field, chemistry. That's why the passion. I spent years training students, helping them prepare for university and their careers. And this passion for teaching led me to create a YouTube channel about chemistry in 2011. And here's a teaser of a radioactivity course I did with some friends. It's in Portuguese, but I hope you can enjoy the view.
Fala, guys nobre, tudo bem? Preparado para reagir? Eu sou Paulo Valim, o seu professor de Química. Muito bem-vindo, muito bem-vinda ao Ciência em Ação. O assunto do nosso curso de hoje é a radioatividade. Quando pensamos em radioatividade, já sentimos logo aquele friozinho na barriga. Lembramos de mutações genéticas, câncer ou até mesmo desastres ambientais. Mas a radioatividade não é de todo mal. Ela também pode nos ajudar a produzir energia elétrica sem contribuir com o aquecimento global, ajudar no diagnóstico e tratamento de doenças e muito mais.
Tá buenaço isso, hein? Mas que barbaridade!
O nosso curso contará com 12 aulas, onde vamos explorar juntos os conceitos e as aplicações da radioatividade em nossas vidas e nos exames como Enem e vestibulares. Através de uma viagem pela vida e história de personagens que foram pioneiros no estudo. E também refletir sobre o papel da mulher na ciência e como, através da educação, podemos construir um mundo melhor para todos nós.
Não faça isso em casa, vamos ver se dá certo. Faz.
Então, se você ainda não é inscrito no canal, inscreva-se, já deixa aquele seu like maroto, aperte os cintos e bora reagir!
Yeah, so that's a bit of it. Yeah. So, in addition to that, I'm also ambassador for the YouTube education in Brazil. Together with Google and the Lemon Foundation, we work to train teachers across the country, not only helping them create a YouTube channel, but also helping them improve their teaching skills on the focusing on how they can adapt their traditional classroom content for online platform, ensuring that they can reach a wider audience and provide quality education to everyone with the internet access. This is a picture from our third EduCom event in 2018, where more than 200 teachers participated. And why I'm telling you this, why is that important? Well, Brazil faces significant challenges, particularly when it comes to access to education. Brazil has excellent free public universities, but they are limited in capacity. Most students who pass the entrance exam, they come from families that can afford private education, leaving many students from public schools at disadvantage. So, according to a study by the Economist Intelligence Unit, our public school system is sadly ranked 39 out of 40 countries. Now, that's where initiatives like my YouTube channel comes in. Today, we are the largest chemist folks channel in Brazil, with over 750,000 subscribers and more than 66 million views. But these numbers, they represent much more than viewership. They represent a movement that makes education more accessible to students who otherwise would have this opportunity. So Yeah, big number.
It's a lot of zeros.
Yeah, it's cool if you think like the students, like our range is 15, 16, 17 years old. They are actually searching for this content, right? And they want to learn something. That's pretty cool. It's not like child bit my finger or something like that, right? So, yeah. And I'm telling all of that because I think that, me and Bruce think, too, that teaching Elixir isn't so different from teaching chemistry. As someone who is just starting Elixir, I recognize in me many of the same challenges that my students, my chemistry students, faced. A little bit overwhelmed, confused, and sometimes, maybe a lot of times, a bit lost. And this is when I crossed paths with Bruce, and soon after, I joined Groxio. Together, we've been working on improving how we teach Elixir, making it more clear and more approachable, just like I did with chemistry. So let me tell you why teaching Elixir is not so different from teaching chemistry. And this is our agenda for today. And I'm going to start by the first. Teaching a hard topic is hard. So what makes chemistry hard to learn? I know that we may have a lot of reasons, but let's talk about 3 of them. Chemistry is a vast and intricate subject, making challenge for many students to grasp. One reason is that chemistry connects with many other subjects like math, physics, biology. And the deeper you go, the more complex it becomes. Concepts, they build upon each other. So mastering one area often requires understanding others. Another difficulty is that patterns in chemistry don't often mirror the patterns in everyday world. For example, the students, they are asked to visualize atoms, molecules, orbitals, things that are far too small to see. It takes a lot of abstraction to understand that what we call water at the molecular level doesn't resemble at all the water we drink. And finally, chemistry requires practice and study. It's not enough to understand the theory. Students must apply it through problem solving, experimentation, and repetition. We need sustained effort and practice to master. Now, I'm going to give the word to Bruce, and he's going to tell you why Elixir is hard to learn.
First, let's give Paulo a big hand. First talk in English ever.
Yeah.
And that's a lot of zeros in 66 million. Initially, I thought, 33 million were for Jose bit my finger, and the other half were don't taste me, Jose, right? But no, that's not true. So I'm Bruce, and I'm going to talk a little bit about why Elixir is so hard to learn. First, let me ask the question, how many of you had an easy time learning Elixir? Whoa! And how many had a more difficult time learning Elixir? Okay, so a relatively balanced set of hands. Now, how many of you have ever had the opportunity to train a Java developer or a Ruby developer in Elixir? And how did that go? It's pretty difficult, right? And I want to talk about some of the reasons that that's true. And we're not going to give you a lot of individual techniques. We're going to give you a layering system for thinking about how to layer our trainings the same way that we layer our software. So let's talk about the problems with learning Elixir, but first I want to go all the way back to the first set of languages that I learned in college. These were called structured languages, and I basically cut my teeth on 2 languages, and when I was, right before I was in high school, I would make my spending money by writing games in BASIC, right? And that was an unstructured language, because I'll tell you, I had a lot of go-tos in those programs. And then when I moved to Mississippi State University, where I got my undergraduate degree, I started studying with Pascal. Anybody? Yeah. No. Okay. Yeah. Quite a bit of hands. And the thing that made structured programming cool is something that took me a long time to get used to. I had to provide the structure to my structured programs, right? Bruce, I can remember Professor Ellis telling me, hey, one way in and one way out. And I'd sneak in a go-to, and I'd find all the back doors to sneak in things that look like go-tos. And he'd say, no, you failed this project, one way in and one way out. And I'm glad he did. Because what that gave me is a way to tie together these complex flows and to wrap those into procedures that I could then turn into programs. And then you could think of a program as something that was organized and clear and familiar because there were a lot of individual blocks that would flow one into the next, into the next. So then the next set of languages that I learned were object-oriented languages. And I would say that the first was C++, though I didn't really code it like C++. It was a lot like those go-tos. It was more like a C++ minus, if you will. But then I found Java, and Java was pretty good to me. And we took these procedures, and we had to call them something else, right? And then we organized those procedures, or those methods, into these tiny chunks around mutable state, and we called these things objects. And then that's what my program looked like. And let me tell you that now I look at this and I kind of shudder in horror, and I look at that green and I think, not really trees and grass, but more like toxic waste. But that's not what I was thinking at the time. This felt familiar to me. I could understand people and cars as objects that had methods on them. Now, we've since learned that that's a bit of a lie, but this did make things accessible to the students that we were bringing at the time because it was organized and clear and familiar. So then, after a while, I circled around a lot of programming languages, and really the big exploration for me was the book, The 7 Languages in 7 Weeks. And I wrote that book because I was afraid. I knew it took me this long to realize that that green in the middle was toxic because it was mutable state. And it took me a while longer to find a language that resonated to me. And I had some friends that told me, hey, you should write down this experience of learning so you could bring other people along in the journey. So I was writing about 1 language I knew and understood, and 6 that I didn't. But Elixir is a functional language. This felt familiar to me. And I could roll these functions up into libraries. And this also felt familiar to me because it was organized and clear and like other things that I'd encountered in the past. But this is a lot like chemistry. So how many of you have had the experience as a young Elixir developer of trying to find a function that did exactly the thing that you wanted to? So throw out some functions that were hard to find. I'm very patient. I'm actually more patient than you. What was a function that was particularly hard to find? What was a module that was particularly hard to navigate? Random. Yeah, random, right? And I don't know if somebody's trolling me, but I had like live examples that this one guy in the front would say, Bruce, use enum.random. And I would always kind of, build this long pipeline of things. But, so it's familiar, but it's broad and deep. And I think that there's something else that's even more difficult here. Because to an expert, these are organized and clear and familiar, but to a novice, these simple functions, when they are called by other programs, get vastly more complicated. Now, we tend to organize our documentation and our libraries with callbacks that look like this. That's familiar, right? And as programmers, we know all we have to do is turn those errors around and everything is exactly the same, right? We have these behaviors. But that's not what a novice sees when you have a behavior. Because we've removed all the context of how that program works that calls our own programs, right? Maybe behavioral problems? Sorry, that's a very bad pun, especially when to take to audience where maybe not everybody has English as a primary language. So I'm sorry, but it's still funny to me. Behavioral problems. So there's no real world analog. Here we are back at chemistry. This isn't where it stops, though, is it? Right? And so when you have things that look like this, it requires a lot of practice and a lot of context. But where do you start? So I know many of you are thinking, hey, you can just read about it on the internet. We can just wing it or improvise. I don't think so. I think we need to rely on known, specialized training methods that make instruction easier. So, excuse me. I want to tell you about a very short window of a trip my wife and I, can you raise your hand, Maggie, that we recently took together. We took a long boat trip, and this section that put us next to this lighthouse. Now, the thing that's interesting about this lighthouse is that lighthouses in the middle of the water are scary because they guard rocks, right? And this is actually a very dangerous stretch of water. So if you've ever seen New York Harbor, and then the bottom of New Jersey, there's this great massive bay called Delaware Bay. But the way it's organized on the Great Loop is that there's a very safe passage that dumps you into this very dangerous situation. And I want to show you kind of our experience. We didn't have anything supremely dangerous happen, but we did have this happen. Yeah, those are banana peels. They were not just banana peels when we started today, right? This slowly peeled our bananas as we got beat to death by the waves out there. So, in order to navigate this small section, there is this saint named Tim. And he works at a marina, and he just, every great looper, which is somebody that says, hey, I want to circle the eastern United States by boat, going 6,000 miles sounds fun over a year of time. Without any experience, he sees these people line up, and he is afraid for their safety, and he should be, because I know what Maggie and I knew, I know what we knew how to do and what we didn't. So St. Tim would have this meeting in his marina, and in this marina, you picture all these aisles of a store. And then sitting in between those aisles, there were chairs, and Tim would walk in, and the briefing was supposed to start where he would teach us how to, not drown. So it was kind of important. But Tim was a consummate teacher. And the first thing that he said was, hey, how many of you are in sailboats? And then everybody says, that's an interesting question. This is the Great Loop. Most of us have motors, but some of you don't. And so 2 hands came up, and there were 2 people in the same sailboat. Everybody else was in a powerboat. He said, you 2 are good. When you flip back over, you have a heavy heel. You'll just pop right back up. You're good. You don't need to pay attention. And from that second, he had everybody, right? He said, you might drown, but he did this in a way that woke us up. And woke us up in a way that wasn't confrontational and had us paying attention. Then the next thing that Tim did was said, here's what I know, is that the weather in this place turns very, very quickly. And there are here these 6 weather buoys that you're going to pass along the way. And if you can find them and you can access them in the morning before your trip and during your trip, you can keep yourself safe. And then he said, now you try. And he would bring people up to his computer or ask people questions about how to navigate his computer and find those particular weather buoys. So now you try. Then he said, you know, I'm sorry for what I said about the sailboats. You're going to be okay. And here's why. So I've since come to learn that this is a common training technique that all training professionals or most training professionals use. And I want to do this together. I want us to learn these together. But the 4 words are anchor, add, apply, away. Okay, repeat. Anchor, add, apply, away. That's terrible. I'm more patient than you are. Anchor, add, apply, away. Anchor, add, apply, away. I'll keep going.
Anchor, add, apply.
Louder.
Anchor, add, apply, away.
Yes. And this is how we are going to, these are the techniques that we're going to use to layer our training. And it makes things much more effective. In Tim's vernacular, hey, sailboats, you're good. Everybody else, you might die. Right? Anchor. Why is this important? Here's what I know. Now you try. You'll be okay. And here's why. So now I'd like Paulo to walk you through something that both of us did instinctively, though we didn't know why. So he's going to walk you through how he used the 4 A's when teaching chemistry.
Hello? Oui. Yeah. So let's just do a quick poll first. Raise your hand if the first thing you learned in chemistry was like atomic models, bonds, or periodic table. The first thing you learned. Wow, cool. Now, raise your hand if your experience with chemistry was more relatable, like learning about global warming, or waste management, or energy resources. Wow, 1 person. Yeah, so let's try to make chemistry more attractive. We can start by anchoring a lesson with a real-world problem. No, a real-world issue that students are familiar with. For example, the massive trash problem in our society. Everyone produces trash. It's something that students see and deal with it daily. So we could ask for them, like, how many of you have taken the trash this week? Have you noticed how much garbage your household produces? Just in 1 day. Now imagine every household in the country where all this trash goes, right? So these questions will bring the problem home for the students. They can relate to it and see how relevant it is for their lives and the environment around them. Then we can add some chemistry concepts. Now that we grab their attention, we can introduce these concepts. We can explain how that to deal with the trash, we need to understand properties that the materials that we are throwing away. Different materials like plastic, metals, or organic waste require different approach. For example, separate trash can be done by using physical and chemical properties like density, boiling point, or solubility. And by adding these basic chemistry concepts, students can start to understand how we can treat and manage waste more effectively. Third, we can now let the students engage with the material in a practical way. We can organize an activity where the students bring trash from home and have them apply different methods of separation. For example, they could separate materials by density, drop different types of plastics or materials in the water and see which will float, which one will sink. We can create some small filtration system with sand, rocks, and cotton, and we can separate the solids from a liquid. So these hands-on activities, the students can apply the chemistry they learned in a real-world scenario related to trash management. And finally, always what the students will take with them. So you want them to leave the lesson not just understanding the chemistry behind separate substance, but a broader meaning of these procedures, right? So a key takeaway would be, okay, we produce a lot of trash, but science gives us tools to manage it better. By understanding the property of the materials that we throw away, we can separate, we can recycle, we can reduce our waste more effectively, helping the environment and ourselves. Now, Bruce will come back to show you how you can use the 4 A's with Elixir.
I'm a little sad. We're not going to solve like global trash or global warming or anything. We're just going to write a little code. But anyway, we're going to use anchor, add, apply, away in the same way that Groxio does in some of their courses. So one of our particular anchors is that Elixir, the language, is reduce. Elixir is reduce. If you think about it, when you're working with LiveView, you take a type, you throw that data type through a function, that's the socket, and then you throw that data type through a function, that's called your handler, and then you convert it to something else, that's called your reducer. But OTP is very much the same way. It's a slow motion reduce engine, right? And many of the frameworks that we use every day use these same techniques. So now we can add. So there's this whole idea that Elixir is reduce, and the thing that I want to add is this concept of CRC. So everybody say it with me, and we don't have time for you to be all quiet and stuff, okay? So CRC, CRC, CRC!
CRC.
Okay, construct, reduce, convert.
Construct, reduce, convert. Construct, reduce, convert.
And you will be surprised at how these techniques change the way that you write Elixir. Right? And so we're going to look at a couple of programming exercises in little snippets that will help us write the game of Tetris. And so our CRC, construct, reduce, convert, and the jobs that these things do are to set up a computation, do a computation, and then prepare for some other layer to consume. Right? Prepare to work, do some work, show some work. Now, the application is something that most professional trainings get wrong. People learn how to code by coding. Most of your time in a coding class should be done coding. And this might be in a mixed project or in your editor. This might be in a live book or some other type of context. But we're going to learn by coding using different types of programming solutions. And so we might write some of our Tetris project, like this module, which supports CRC. And here I have a constructor and a reducer. This might not be something that you would write in production code. You might just throw out a tuple. But having the new function like this will help cement the concept that sometimes in Elixir you have something like OTPs init, where I need to anchor, I have an opportunity to change a value to something that is easier to consume. And then that move down, I have a point that's in the middle, and I return a point that's moved down one row. And as we start to layer these concepts, what happens is we start to build layering within the CRC. Right? So this rotates a point 90 degrees. And those two functions are swap y and x. That's kind of like a mathematical reflect. And the flip left to right is like a mathematical mirror. And we might apply the rest of this in a live book where we've coded our project like you saw in Mix. And then we basically connect our live book to the project. And then we drop in a little bit of code to prepare us to do the work. And then we can start to call these constructors. And what I'm really after in this case is for the student that's working with me, I want them to be able to visualize the work that they're doing. So I believe that this is where Paulo had his breakthrough when he was learning Elixir with us. Right? So one of the things that we do here is we call a constructor, but you can't really visualize that, right? So now what I'd like to do is wire this into the canvas in such a way that now I can see a point, or see multiple points that I might build with something like a for comprehension, or translate a single point to a list of points so that I can draw a shape, or take a shape, drop that twice, rotate it to the right, and then drop it to the page. This is all CRC, construct, reduce, convert. This is what our Elixir programs look like. And when you can see in slow motion that Tetris block manipulated in a way that you're used to seeing it on the arcade screen, something magical happens. I could start to see how to break down my work. Okay, so before we close out, I want to talk a little bit about some techniques that we use along the way, and sometimes in add and sometimes apply. One of the things that we do is we try to present memorable mnemonics, right? CRC is maybe a bad one. Probably a better one is, how many of you have read Designing Elixir Systems with OTP? Okay, a good chunk of you. It's a really good book. And one of the things that it does well is it sends you away with memorable concepts for designing your systems. And it does so with this mental mnemonic. Do fun things with big, loud worker bees. And these are the layers of a typical Elixir OTP application. And all these first letters translate to data, functions, tests, boundaries, life cycles, workers. And notice we use a vocabulary that's familiar to the student for the way that supervisors work. We could call these supervisors, right? Or we could call them life cycles, because supervision is about starting, stopping, and restarting things. So a couple of other techniques that we use, we'll often do role plays so that we take a bit of complex code and have each student describe one function and then tag the next person in line. And we do this for OTP. So we'll go to the init and then we'll go into go from one function to the next, and it really helps. It helps the students understand. For Phoenix, we'll do role plays for the live view lifecycle, for endpoints and the flow of a Phoenix request into the layers of the system. We do role plays for concurrency. This is one of our primary anchors, where we say, okay, you're a banker, you do a debit, you do a credit, and then we'll build a race condition and teach people why mutability is evil. Right? And the other thing that we spend a lot of time on is visualizations, so that we can help people mentally take this tangle that we talked about earlier and then unwind it. And so one of the ones that I like a lot is the idea of a subway map, right? The train is moving through our life cycle. But the main thing is that these metaphors open learning channels. Okay, so I've been talking at you long enough. It's time to bring Paulo over here to wrap us up. And of the four, anchor, add, apply, away, what's Paulo going to do right now? Away, okay.
Yes. Okay, so our away would be think about layering your training the same way that you layer your software. That would be our away. And we can start with anchor. Then we go with add. Then apply. And away. And it works. Questions?
Do we have time for a question or two?
If there's questions in the audience, we can take them from here real quick. Somebody raise your hand. I'm going to check real quick on the Vuva app what we're going to have.
Okay.
I love this so much because I hope I can take some of that into the Elixir Berlin meetup and apply some of the learnings here.
Yeah, so a good piece of advice with your Elixir meetups is if you have a lot of young Elixir developers, I would say three things. Coders learn to code by coding. The second thing is that it's a vulnerable thing to make mistakes in front of someone else, especially in a meetup setting. So the third thing is you need to learn to love each other for that to happen. So spend more time on relationships than you think that you have to.
Thank you so much for that advice. And you guys going to be around? So if you have
We're going to be around.
Yeah.
how to build your community or anything else on teaching and learning, please reach out to them.
Oh, and also give Paulo a hand for his first English talk.